Next paper number EN054. The topic is insect classification and alert system using CNN, right?
Yes, ma'am.
Okay, you can share your screen.
Everyone, my name is HARSHAL Kasne. I'm from PCET's NMIT from Department of Electronics and Telecommunication with my group members Dheeraj and Tanuja, hereby presenting our paper on insect classification and alert system using CNN, guided by Dr. Vilas Devtare. So the introduction, in introduction, we talk about the problems. So the problems are every year nearly 7 million deaths are caused by insect-borne diseases. So every year nearly 7 million deaths are caused by insect-borne diseases and pest, and 40% of global crops are destroyed by the pest. So it is important to address this issue, and it all happens because of the concerned authorities take steps to stop the spread after a number of cases start showing up. In some agriculture cases, all the crops are destroyed until the some necessary precautions are taken. So as a solution to this, it is important to early detection of insect and pests is important, and it is important to build a system which can detect the insects and alert the authorities if that system is situated in a remote place. So we propose a system which consists of a camera inside a trap, which will capture the images and send it to the processing unit, where it will give to the our CNN model, and CNN model will classify the image, and if the insect is detected in that particular image, then it will send a SMS to the concerned authorities. So this is the primary pipeline for our CNN model training. First is collection of a raw data set, then data augmentation, data segmentation, then feature extraction, then for the mix-up of signal, fully connected layers, then model training, and then insect classification. So first step in our pipeline is collection of data set. So in this paper, we have collected 1,448 images for 14 different classes and pests, insects and pests. That means these are 100 images per class, but to build a high accuracy model, it is important to have numerous amount of data. uh, so to solve this issue, we have used data augmentation, and augmentation is also helped us to give the different angle of object to the model, as CNN is itself not capable of rotating objects. So data augmentation is used, which increase our data set by 3 times. Then data segmentation is used, as many of the insect images were captured in like agriculture or forest area. There was a lots of background which has to be eliminated, uh, which has to be removed. So for that particular, to focus on the object, data segmentation is used. Next is feature extraction. uh, our CNN model use 10-layer feature extraction model, which consists of 5 convolutional layer and 3 max pooling layer. So it is a backbone for our model. So it is important to know how this works. So actually, convolutional layer works as we have used 3 by 3 kernel size for filter. So like in the image, you can see in the middle there is a cross line filter. As you can see, the ones are aligned diagonally. So that filter will convolute over all over the input data and will produce a convoluted feature matrix. In first layer, there are 16 such filters will be applied. So we will have 16 convoluted features layers. Then those 16 layers will be provided to the ReLU layer. Now, many filters might have negative uh, negative value between them. So that will produce a negative calculation, and that negative value is not useful, because the negative value points out that it's not a filter, or it's not that a feature there is there. So that's why ReLU layer is used. Then max pooling layer helps us to retain the only prominent feature from the input data. So it will uh, the 2 by 2 window will convolute over the input data, and will yield us only that window. With the fully connected layer, Then fully we have one used layer will mix up the signal. As in CNN, the fully connected layer will mix up the signal to give the another view to the model for the classification. The softmax function will provide us the probability of that particular insect being present in the image. So when we trained our model, we achieved 82% training accuracy and 85% testing accuracy. As you can see, there is very small gap between the testing and training accuracy. It is so that it shows us that the model can be trained for another more epochs for the better accuracy model. Alerting system. When we provided the image with one unseen data, one unseen insect data, the model given us this model provided us this with this message saying mosquito detected in the uh, detected by the system in your area. Now, if the system has a better connectivity with the internet, we can use software as a service solutions. Or if the system is in a remote place, we can use GSM or LTE model to send the messages. Applications can be used by municipal corporation to take precautionary method to stop the widespread of the disease or insect-borne diseases. In agriculture field for early detection of pests, these are the applications. These are the some of the references that we taken the help of. Thank you.
Harshal, a simple question is there. Which camera you used for the implementation?
Sir,
you are using a ready-made data set.
Sir, actually the data set has
For
been
training
collected
and testing
from,
purpose.
yeah, the data set has been collected from the internet. Like there are sources from like Kaggle, from some of the images from the Google also, and the one data set is there called IP102, which consists of 102 species of different pests. So from that we have taken the data.
Okay.
Thank you, sir.
Thank you, Harshal.
Thank you, Harshal, for sharing your knowledge with us. Okay.
Thank you, ma'am.